but we have something called a determinant. So see this thing here, this symbol with the two parallel lines? I need to teach you how to use that. When you were a little kid, someone said to you 5 plus 6 equals 11, and you slowly learned that this symbol here meant addition. So that's called an operator. Well, this thing here, this parallel lines thing, it's also an operator because it induces a mathematical process or operation. And the following is true for it. If you have that thing there, which is called a determinant, there's your determinant. The way that you execute that instruction is like so. Two brackets. It's always that. Whatever I wrote in black here is always true. It's two brackets minus two brackets. So for every single question like this, okay. And what do you put in those brackets? That's the key. So you put the following number sequence: 5, 4, 3, 2. So the way that it works is like so. You put these two numbers first. That's this one. And then you put these two numbers after. That's this one. So you do the diagonal in green, you multiply, and then you subtract, and you do the pink one. That's the process. It's not a difficult thing to execute as a command, but it is what it is. So if you multiply that out, you get 20 minus 6 is 14. And that's it. What do you think? Is that tricky? Okay. So it's not too tricky. That's good. The purpose of this is if you understand this notation, that if you understand how to execute this instruction, then me showing you the procedure for doing my alternative to elimination is a lot easier to process, to do. So the reason that you're learning this instruction is so that you can do a process for linear systems that's much faster than elimination, at least when the numbers are bad. Is that cool? Okay, so try it for the next one, see what you get, and then we'll discuss it. All right, so let's put these numbers here. 3, -5, 2, 3. What did you get as an answer? Let me hear some people say some numbers. 19, anybody else? Steven, Khalid? Yeah, I'm with you. It's not very democratic, but 3 votes is enough here. 3 of 26 is good. So I did that at command, and so did your friends. There you go. Let me hear from some other people. Do you find this process easy to do? What do you think? Easy to do this thing? Hopefully. Thanks, Jaden. Matthew. Amiri. Oh, okay. We're getting. Thank you. I'm getting overwhelmed by the ease. Okay, good. Very nice. Thank you for responding. So that's well over half the class, I think. Hopefully. Okay. -4, 5, -2, 1. So that's -8. Okay. Yeah, I got -18 on my sheet. I'm just checking. Yes. -18 is cool. Okie dokie. So you understand the skill. The only difference between this and tougher ones is decimals. But before we go on, actually, I show you a full way to solve a question using this stuff, this operator. determinants, I should say. Let's have some fun. Solve for x. Solve for x. What value of x did you get? I'll give you guys like 1 minute. I'm not trying to like push you, but just take a minute and try it. Okay, we got a 5. Anybody else? Wow, okay. Okay, you guys are good. You guys are good. You guys are embarrassing me here. It's good. So, x, 2, 1, 3, x, 3. You can put your 1, 2, or 2, 1. Doesn't matter. So there it is. 3x equals 15. If you're wondering why does the method work, just remember that there is a proof behind it, which you are not responsible for, but the all it is doing is taking all the stuff that you could do with elimination and almost, in a sense, automate it. I don't mean like you don't do it at all. I'm saying that it's a thing that you could program. So this method is called Cramer's rule. Cramer's rule requires 3 calculations. It requires 3 determinants. So let me write them down here. And then we'll discuss how you actually do it. It's not, guys, it's not really hard. I promise you that if you do a few of them, and we will do a few of them. No, no, Cramer much older, much older. So we're gonna do 3 of them. Okay, that's good enough. So the first one's this one. 5, 2, 3, 8. I'm gonna call this one D. Just like that. So let's take a moment and do that. We'll do 5, 2, 3, 8. What do you got? 5 times 8 minus 3 times 2. Can I have a number there? 34. Yeah, I agree with you. Thank you, guys. Adnan, thank you. Jaden. Okay, so that was pretty easy. Can someone tell the class, or you can go on the mic if you want for this one, where the heck did I get 5238 from? Can you look at the original question and tell me where 5238 came from? Yeah, variables. Yeah. See, when you look at the variables, it's the actual, just the coefficients. So just like elimination, you have to be thank you, Ethan. You have to be very organized. You have to say the coefficients. You can't have x and y here and then y and x there. They have to be super, super, super consistent. Now I'm going to make you do another one, and I'm going to call it d subscript x. And let's see this one here. So let me see what I'll do here. So how does what I compare here? How does it compare to the previous one that I wrote? Are they the same? Are they the same so far? Do these look the same so far? Yes, I'm assuming yes. Okay, good. So here comes the new thing. This is the new thing, guys. I'm going to put 11 here and 7. So tell me in your own words in the chat, what did I do here? I want you to use the word replace. What did I do? I replaced x. Okay, I'm going to take you, Sean. I replaced the coefficients of x with the right-hand side. That's called the right-hand side. So that's what I did there. RHS is right-hand side. And then I'll do the same thing here. Replace the coefficients of y with the right-hand side. I'll put 5 and 3, just as they were from the original. And now I'll put 11, 7 here. This method, many people will say that it is more writing than substitution or elimination. But the reason that this method is nice, in my opinion, is for two things. Three things. One, when the decimals arrive, this method's better because you don't lose any rounding errors. Two, it's organized. Three, it's something that I could program. And if you don't believe me, if there's time at the end of class, I will open Excel and I will write a program in Excel for this, for any Cramer's rule question. Obviously, without like bugs or error detection, I can probably write the code in like 5 minutes flat. And I'll show you how to do it. Maybe even 2 minutes flat. Maybe we'll do a coding challenge. We'll code Cramer's rule in a minute. What do you think? You think I can do it in a minute? All right. So I'll show you that code. If I have time, I'll do it with you. But it's definitely fun to do. Anyway, we're going to call this dy. So why would I call it dx? Do you think that's a natural name for it, dx? Because I'm replacing the coefficient of x. And then dy with replacing the coefficients of y. It's a very natural thing to call it. In the textbook, they call them D1 and D2. They call them D1 and D2 in the textbook, okay? So for that reason, if you go to page 2 of my notes here, you'll see that I have the algorithm right there. See them? D1, D2. The reason I use D1 and D2 is because the textbook does. So because many people look at the textbook as well to learn the lesson. That's why. Anyway, we need some numbers here. So let's write these numbers down quickly. So we have 11.8, 7.2. Can I have a number for that, please? Can someone confirm? I'm not looking at my answers. Thank you so much, guys. And the other one? We got a deuce there. Okay, that sounds right to me too. But we're almost done the question. So the final step is this. This is the final step. X is equal to dx over d, and y is equal to dy over d. That's 74 over 34 and 2 over 34. Of course, you can reduce these if you like. I would encourage you to. That's 37 over 17, and this is 1 over 17. I can't prove this to you here, but one of the things I like about elimination is when the numbers are easy, I can solve it in my head. And many people in here in this group, I'm pretty sure that if you train yourself, especially with just the smaller numbers, you could probably solve this in your head. There's also a further advantage to Cramer's rule, which is the following. If the question says solve the system, I mean, this is true for elimination and substitution also, but one thing is that if you want to just solve for one variable like x or y, you don't need to do all of these things. If I want to solve for x, all I need is d and dx. I don't need dy. So you can really target what you're solving for. So anyway, that's Cramer's rule. We're going to practice this approach a couple more times. 11 over 7. Sorry. Which question, Yuzan?
Hello?
Yep.
So when it says replace the coefficients of x with the right hand side, you put 11 over 7 on the left side, and you multiply 11 by a and whatever. Then when you replace the coefficients of y, you put 11 over 7 on the right side and you multiply 11 with 3. But I want to know why you changed the position.
Okay, so it's part of the procedure. Thanks for your question. It's part of the procedure that you replace the column that is associated with the variable. So what I mean is that if you're solving for x, you're replacing the x column with 11.7 because that ultimately leads to the solution of x. It ultimately is just a pattern. It is a pattern that behind that pattern is a proof, and the proof is not really something that I intend to present here. But If you take elimination or any of the methods like substitution, and you try to take all the numbers and kind of automate it and organize it, you'll end up with this. Two 526, 2 526, 3 633, 3 633. 3 4, 3 4. Okay, it's coded, done. I'll put it on Blackboard, okay? What do you think? How do you like my solver? If you ask me to do this with with elimination or substitution, it would suck. But anyway, over here, let's make the numbers bad. Oh no, fractions. What you can do in Excel is you can actually go to Format, here, Format, Cells, and you can go to Number or Fraction. And let's just put crazy fractions. Let's put it accurate to 3 digits. Boom. There it is. Now it's reading, it reads a little funny here, but that's -3/11ths, and that's a proper fraction. That's 5 and 7/11ths. I don't like proper fractions, so hopefully they have it without proper. And sadly they don't. They don't. So we could fix that if you want. Actually, forget it. I don't want to fix it. Let's put decimals here because I don't want to have any issues. So I'll put decimals here with three decimal places is fine.